Michael, what's today's audio topic?
Today, the SMSL clock generator G1 arrived, so that's what we're talking about.
Did the clock generator have any effect?
I was expecting it to, but I couldn't tell any difference at all.
That's too bad.
That's just how audio goes sometimes. Results don't always match expectations. Still, let's talk about the clock generator G1 this time.
Master wants to hear about the clock generator too, right?
Yes, I want to hear.
What equipment are you using?
The music source is Amazon Music. The network streamer is LinkPlay's WM Ultra. The DAC is SMSL's D200. The amp is SMSL's PA200. And the speakers are B&W's 805D4. I connected the clock generator G1 to the D200 and compared with and without the clock generator. Switching between the D200's internal clock and external clock is done by selecting internal clock or external clock on the D200's display.
How much does the G1 cost?
The G1 costs about $500. It's on the cheaper side for a clock generator.
I see.
Let's start by explaining the front panel of the G1. The front panel is completely bare, as shown in the photo. Its design matches the D200, so stacking them creates a unified look.
There's no power switch or buttons or anything?
Absolutely nothing. Only an LED is present. This is a distinctive feature. It glows blue when powered by AC and red when powered by DC.
So DC power is possible.
That's the interesting part about the G1. I think it allows DC input to reduce the impact of AC power noise.
That's quite an intriguing feature.
This time, I tried both AC and DC power.
You did a great job.
It would be a waste not to try the DC input since it's there. Now, let's move on to the rear panel. As mentioned before, the rear panel only has 4 clock output terminals, a DC input terminal, and an AC input terminal. There's no power switch either.
So the G1's power stays on constantly?
Exactly. The G1's clock uses an OCXO, which requires warm-up time for temperature stabilization. OCXOs are sensitive to temperature changes, so they can't be used until they reach a stable temperature. That's why the power needs to stay on constantly. However, this warm-up is only needed when using AC power. The blue LED changes from blinking to steady, indicating it's ready for use.
So warm-up isn't needed when using DC power?
Warm-up would probably be needed with DC power too, but DC power can only supply a constant current. With AC power, during warm-up, it draws more current to heat the oven. With DC power, there's no dedicated warm-up time, but I imagine it still takes time to heat the oven.
Clock generators are delicate, huh?
If you can't manage the temperature properly, an OCXO loses its purpose. The accessories are a power cable and one BNC coaxial digital cable.
What does BNC stand for in BNC coaxial cable? Never heard of it.
BNC stands for bayonet Neil-Concelman. B is short for bayonet, referring to the structure where you insert it and then twist to lock. N is for Neil, C is for Concelman, the names of the connector designers.
How do RCA coaxial cables and BNC coaxial cables differ?
The coaxial cable structure is the same. RCA and BNC refer to the connector shape. The difference in structure between RCA and BNC connectors lies in the connection method. RCA connectors have a simple plug-in pin structure, while BNC connectors use a bayonet lock mechanism that twists to secure. Therefore, BNC provides a more stable connection. Additionally, RCA may not maintain consistent impedance, but BNC can be precisely manufactured at 50 or 75 ohms, making BNC terminals common in clock generators. Now, regarding the sound from the AC power supply. As explained earlier, the AC power supply required a warm-up period of about 2 to 3 minutes. While the blue LED was flashing, it was plenty of time to build anticipation about what the clock generator was truly capable of.
So the result was no different from the D200's internal clock?
Exactly. I bought the clock generator with high hopes, so I listened intently, trying desperately to find a difference in sound. I really wanted to find something good about the clock generator, but I couldn't tell any difference from the D200's internal clock.
So that's where the DC power supply comes in.
Exactly.
The G1 doesn't come with any parts for a DC power supply, right?
That's right. So I had to prepare the DC power supply components myself. For that, I bought an AC adapter and a cable. I bought a GON-type AC adapter to reduce noise. The cable needed a USB Type-A connector on the AC adapter side and a 5.1 by 2.1 mm plug for the G1, so I bought a compatible product.
After all that prep, you'd hope the DC power would improve the sound.
Yeah, when I connected the DC power to the G1, the red LED lit up. My hopes rose that while AC didn't work, DC might improve the sound quality.
So the result was no different from the D200's internal clock?
Exactly. I was a bit disappointed with the AC power input, and even more so with the DC power input. I really couldn't tell any difference from the D200 at all.
By the way, what exactly is the difference between AC and DC power?
Let's summarize the difference between AC and DC power here. AC stands for alternating current, DC for direct current. The way the current flows, with AC power, the direction changes periodically, while with DC power, it always flows in one constant direction. The advantage of AC power is that it doesn't require a converter. You can use it directly at home. Since voltage can be easily stepped up or down with a transformer, it's also easy to use with high-power equipment. The downside of AC power is its susceptibility to picking up high-frequency noise and hum noise. It's also affected by other appliances like refrigerators, fluorescent lights, and Wi-Fi routers. The advantage of DC power is its ability to drive devices with stable voltage. It has fewer noise sources and offers greater silence. Using an independent DC power supply allows for audio tuning. The downside of DC power is that an AC to DC converter is needed for external power supplies. High-power amplifiers require large-capacity DC, increasing cost and heat generation.
So even though a converter is needed, DC power reduces noise, right?
Exactly. DC power includes linear power supplies, switching power supplies, and battery operation. This time, we used the cheapest and simplest option, a switching AC adapter. Linear power or batteries might have been more effective.
Based on what you said before, introducing a clock generator should have reduced jitter effects, right? Why didn't the clock generator work even with the DC power supply?
I suspect it's because the only device outputting the clock signal was the single D200. Using the G1 definitely made the clock signal more accurate, but for just the D200, its internal clock was probably sufficient.
Does a clock generator become more effective when connecting multiple devices?
Probably. It's clear that G1 outperforms the D200 internal clock. Yet we saw no difference because we couldn't leverage the G1 properly. I think clock generators truly shine when synchronizing multiple clocks.
Aren't you going to add other digital gear to see the G1's effect?
I won't go that far. I don't need any digital gear besides a DAC. Also, with a different DAC, even just one unit might show the clock generator's effect.
True. There are all kinds of digital gear out there.
With this combination of the D200 and G1, I couldn't discern the effect. But I was satisfied because I wanted to try using a clock generator at least once.
Experience is everything, right? Master, this clock generator discussion was interesting, wasn't it?
Yes, interesting.